LeetCode number 8, string to integer, or A to I, might sound simple, but it mirrors real-world backend issues where parsing user input or API data has to be exact. One wrong read, and you could trigger overflows or hidden bugs. The twist? You can't use built-in parsers. Every character matters. So how do we handle messy strings, leading spaces, rogue signs, and massive numbers, all by hand? Let's break it down. Time to dive in with a brute force approach. We'll walk the string step by step, no shortcuts, just clean logic. Let's see what it takes to build this parser from scratch. We kick things off with some setup, a pointer to track our position, a default sign set to positive, and a result variable to hold our number. We also grab the string length to avoid going out of bounds. With that in place, we scan past any leading whitespace. This helps us lock on to the first meaningful character, whether it's a sign or a digit. Next, we check for a plus or minus sign. If found, we update the sign tracker and move the pointer ahead, ready to read the digits. Now comes the heart of it. While the current character is a digit, we build up the result by multiplying the current total by 10 and adding the new digit. Classic number construction. But as that number grows, we have to be careful. If the signed result ever breaches 32-bit bounds, we immediately clamp it to the nearest limit, either integer min or max. Each time we grab a digit, we move the pointer forward and keep scanning, as long as the characters are valid. Once we're out of digits, we multiply the result by the sign and return the final value, making sure it stays within 32-bit integer range. This solution runs in big O of n time, with at most 200 steps for a 200-character input, and uses constant space. But the real win here is overflow handling. Around 10 digits, a 32-bit int can overflow fast, so clamping early is key. In the end, we built a reliable, low-level parser that handles whitespace, optional signs, digits, and overflow, all manually. It's big O of n time, constant space, and gives full control over edge cases. That's huge for real-world tools like database parsers, telemetry decoders, or protocols where one bad conversion could corrupt your pipeline. Sure, regex might work for simple cases, but this approach catches the weird stuff. And in interviews, explaining this step by step is a big plus. So, can you clean it up? Make it reusable? Where else could you apply overflow-aware parsing? Keep coding, keep questioning, and keep debugging with the duck.